Hello class, and welcome to Unit 3 of Grade 10 Applied Mathematics. Unit 3 is called Linear Systems. So I want you to think about the word or the expressions linear and system. Linear, folks, means a relationship that when graphed creates a straight line, and system means more than one. So what we're going to be doing is taking a look at two equations or two lines and figuring out how to solve them. All right, so in order to graph two lines, we need to review how to graph one line. So let's take a look at our warm-up here, ladies and gentlemen. So for number one, it says graph each of the following. Now I need to make a special note here, class, that whenever it says to graph in this unit, you have to use an actual grid. You can't just sketch it, okay? Because we're going to need some accurate points from the graph. So that's why you're going to be making sure you use an XY grid. Again, you can print them off my website or come grab some from the back of the room in class. All right, number one, 1a, y equals negative 3x plus 3. This is one method to graph a line. This is going to be the the slope and y-intercept method. So from the equation, notice it's already in the form y equals mx plus b. I know my slope equals negative 3. But when I want to do something about graphing it, I'm going to keep it in terms of rise over run. So I'm going to make it over 1, because whenever you take a whole number, change it to a fraction, you put it over 1. And normally you go rise over run, but if it's negative, we're going to fall 3 and we're going to run 1. And we always run left to right, ladies and gentlemen. And the second part of the equation that's important is the b equals 5. That's your y-intercept. And that's where we're actually going to start. So let's start with that point. So on the y-intercept, draw a dot at 5. Because that's what the y-intercept is. And then from there, ladies and gentlemen, we're going to use the step pattern from our slope. So it tells us from the slope being negative 3 over 1, I'm going to go down 3, 1, 2, 3, over 1, draw a dot. Keep going. Down 3, 1, 2, 3, over 1. Keep going. Down 3, over 1. So you get a nice pattern. And what we're going to do is draw a line right through your grid, ladies and gentlemen. So I'm going to take my ruler, straight edge, guys, and you're going to join them right through. Okay, I've just got to make sure I put arrows on both ends, so just give me 1 second. So go arrows on both ends, and I'll make that a red one since I underlined it in red. Okay, and then we'll identify the equation by writing it on. So y equals negative 3x plus 5. Great. That's one method. So down in 2a, it says describe the three methods to draw a line. That's going to be the slope and y-intercept method. So slope and y-intercept method. That's the easiest one and the quickest one, folks. So please make sure you know how to do that, or come see me for help if you have trouble. The second method, ladies and gentlemen, is when you've got the x and the y-intercept. Remember in the past, folks, to get the x-intercept, you let y equal 0 in the equation, or if you're trying to find the y-intercept, you let x equal 0 if the equation's given. If the equation's not given, then you just simply go with the intercepts that are given. So it says x-intercept of negative 2. So on the x-axis, ladies and gentlemen, find negative 2 and put a dot. Okay, let's do the same with the y-intercept. The y-intercept of 4. So again, on the y at 4. And then we're going to draw a line for that. We're going to use the same grid just today, okay? So we're going to get in the practice of putting more than one graph on a grid. Just need to fix this up a bit so it looks a little better. Okay, I need to make sure you've got arrows on both ends, folks. Okay, and we're going to put a color, and what color should we use here? Blue, since I've been choosing blue for that one. Okay, and the equation isn't given, so in this case, just put b in brackets. Okay, so you have some way to identify it. And so that's the second method, which is called x and y intercepts. Okay, and the third one, as I zoom back up, is the table of values. So all you need to do, folks, is plot the table of values. Okay, so negative 2 and 6, negative 1 and 3, 0, 0, 1, negative 3, and 2, negative 6. Okay, I'm going to draw a line through that. I'm going to make sure I got arrows on both ends. And folks, we don't have an equation, but can we come up with it in this case? Absolutely. If you don't remember, we can find b right away. So b equals 0. It's your y-intercept. And then to find the slope, remember we do the change in y over the change in x. So take the lowest and subtract the lower and subtract the upper value. So it's going to be negative 3 in this case. And change in x is 1. So slope equals delta y over delta x, which gives you negative 3 over 1, which equals negative 3. So therefore, you can give me that equation. Now we can plug that in. Y equals slope, which is negative 3x plus 0, which is just negative 3x. You don't add the plus 0. All right. So the third method, ladies and gentlemen, is table of values. So those are 3 ways you can draw a line. And sometimes instead of writing table of values, you might see me use T of V. That's the short form for table of values. Okay, folks, let's get on to solving linear systems. So there are 3 methods, ladies and gentlemen, to solving linear systems. Today we're going to focus on one which is called the graphing method. Okay, if you're curious, the next 2 methods are called substitution method and elimination method, and we'll use them later on. Those second and third ones I just talked about, substitution, elimination, those are an algebraic method, so you won't be using graphing all the time, just for this first method today. All right, so ladies and gentlemen, the key, or when solving by graphing, the solution or the answer occurs at the point of intersection. And we're going to use P of I for a short form. So you're going to take 2 lines, put them on a graph, and where they intersect or where they cross is called the point of intersection. So you will always have a solution in a linear system unless the lines are parallel. And if the lines are parallel, they have the same slopes, so you won't be able to get a point of intersection. There will be no solution. All right, so here are the steps, folks, ladies and gentlemen. I want you to write down, and I want to put this in a box, because right now you're going to say, Miss R, these steps are pretty easy for me to do. However, at the end of the year, when you're studying for your final exam, you're going to have to know all 3 methods, and you're going to forget which method does which thing. So make sure you've got these down in your notes, because that's a great tool to help you for this unit test coming up, as well as for the final exam. So step number 1, create the equation for each function. So when we get into word problems, you'll be doing that a little later, but for now, I'm just going to give you the equations. Okay, step 2 is to identify each equation. What you're going to do is just label 1 with a circle around it, and 2 as the second one with the circle around it. Okay, method 3 is to graph each line accurately on a graph paper. So you want to make sure you're in pencil, you've got a sharp pencil and a straight edge. You can't just guess with a squiggly line or it's not going to work, because we need to be very precise when we're finding that point of intersection, folks. Okay, I don't want to erase, I want you to be able to see what it is, the point of intersection, right? P of I. Okay, so after you graph 2 lines or both lines, then number 4 is to locate the point of intersection. So you're just going to circle it like this and write down P of I and put down the actual ordered pair. You're going to write it down. And then on your work on the side, you're going to throw a concluding statement in, which is solution xy equals 4, 6, for example, wherever it is. Or you could write down solution occurs when x equals 4 and y equals 6. Most people like the short form. It's easier and it's quicker for them to do. And then, folks, ladies and gentlemen, if it asks you to check, you're going to sub your solution into left side, right side check for both equations. So that's what's different this time. Okay, let's just take a look here. Please note that in this unit of linear systems, we will compare linear functions. For each question, please expect to have at least 2 equations with the same 2 unknowns. That's going to be very important when we come to doing word problems, and we've got to create them ourselves. Okay. And just remember, folks, at the point of intersection, the values of x in the 2 equations are the same, and the values for y are the same. And that's going to be important in real life. I'm going to explain that later when we do a little investigation in the textbook a little later. Okay, number 1, solve the linear system graphically, check your solution. So notice, ladies and gentlemen, that the equations are given, so that would be step 1's already done. If we had a word problem, you'd have to come up with these equations. Step 2 is to label them 1 and 2. So we've got 1 and 2. Always do the first one as 1 and the second one as 2. And then our next step is to graph each equation. So if I take equation 1, for example, and I move it down here, okay, it's not in the form y equals mx plus b, so I'm going to do that. I'm going to leave the y where it is. I'm going to move the other two terms over. So the 2x is going to come over, become negative 2x, and the positive 5 is going to come over, become negative 5. Based on that, I now know my slope equals negative 2, and I'm going to put it over 1 because I'm going to do that step pattern, and b equals negative 5. To graph this line, I'll use blue. We're going to start at the y-intercept of negative 5. And from there, we are going to drop 2 because it's fall. So fall 2, run 1. Fall 2, run 1. I'll just do one more here off the page. Now we can get a line. Now, ladies and gentlemen, we're not sure where these lines are going to cross. So don't just draw a line joining the 4 dots. Draw it right through your entire graph. Okay? Because who knows where we're going to have an intersection point here. Okay, that looks pretty good right about there. Maybe a little bit up higher. Just trying to get there. That looks good. And I'll put that in blue. And don't forget, folks, that you need to have arrows on both ends and label them. So you can just label this equation 1, ladies and gentlemen, okay? Because we've identified already in the question that it's equation 1. Okay, so I will do that. I'll just put 1 with a circle around it. Okay, equation 2 I'll do in red. It's already in y equals mx plus b form, so I know my slope equals 2/3 and b equals 3. You have to show me that as showing your method of graphing. Otherwise, do a table to show me table values, or show me your x and y intercepts if you're choosing that method as well. All right, so for graphing equation 2, we start at 3 on the b, or on the y-axis, which is your b. Then from there, we're going to rise 2, run 3. Rise 2, run 3, rise 2, run 3. Then we're going to take your ruler and draw a straight line all the way through this. Okay. And then I need to make sure I've got arrows on both sides. Okay, make sure you've got, I'm just going to color it red. Okay, and don't forget to label it equation 2. So that was this next step, graph both lines. Once we've got the lines graphed, see how it has to be pretty accurate, folks? We need to now do the next step, which is find the point of intersection. So we circle that, and we then say point of intersection, okay? So P of I, and look for that ordered pair. Write it in here. It doesn't matter where you put it as long as it's on your graph. I have negative 3 and 1. Okay? And then down here to do your concluding statement, not on the graph, you say therefore, solution, that's a short form for solution, by the way, xy, meaning the ordered pair where my solution occurs at, is, and put it in order, negative 3 and 1. All right, so we've solved the linear system graphically. Now we need to check your solution. So we're going to do a left side, right side check for both. So tell me, hey, Miss R, I'm doing a check. So write check down, set up left side and right sides, and I'll put this equation 1 here, and I'll do 1 here. Left side, right side, but this is going to be for equation 2. And you go back to the original equation, folks. So for equation 1, it's all on the left side, so it's going to be 2x plus y plus 5, and the right side equals 0. Again, the left side and the right side are dependent on the equal sign. For equation 2, we have the left side equals y, and the right side equals 2/3 x plus 3. Now what we do, folks, is we sub in our answer, our solution, which is Where we see an X, we're going to put a -3. Where we see a Y, we're going to put a 1. So it's going to equal 2 times -3 plus 1 plus 5. Let's simplify that. So it's -6 plus 6, and that equals 0. So far left side equals right side. We don't make a statement yet until both of them equal. So let's prove that both of them are equal. So for equation 2, y equals 1 on the left side. On the right side, we're going to sub in x equals -3, and then we have plus 3 as well. Look to cancel here, folks. 3 goes into 3 once, but it's negative, so it's going to be -1. Okay, so we're left with -1 times 2, which is -2, plus 3. Just going to make my chart a little longer. There we go. Okay, and -2 plus 3 equals 1. Notice that left side equals right side for both. So you can say, since left side equals right side for both, therefore, solution, and just put your solution, which is -3, 1, is correct. And just put a check mark. Or you can write down is correct or is accurate. Okay? Awesome. Any questions with that? Please come see me. Let's go to example 2. Example 2 says to see investigation in text on page 119. So pull your text out, okay? If not, just pay attention and I'll read it over. It says, which is a better plan? 2 banquet halls are being considered for a party. So later on in life, guys, you're either going to get married or host an anniversary party for your friends, or maybe or for your parents, or you're maybe going to throw a party, a special birthday. You're going to have some type of event where you're going to be renting a hall usually. So in this investigation on 119, it says Hall A will charge $50 per person, whereas Hall B has a fixed charge of $2,000, which is your hall rental, plus $33 per person for the meal. It says, which graph offers a better deal? Okay. So it supposes we talk about the equation. So the equation for the first one would be y equals 50x, which means no matter how many people they go to, for every person that comes, it's going to be $50. Sometimes we change the y and the x to cost equals 50n, which means the number of people. The second equation, or the second hall, we'll have an equation of y equals 33x plus 2,000. Okay, that's your fixed rental hall. Okay, plus $33 per person. So say I'm planning a wedding and nobody shows up, I'm still going to owe that hall $2,000. Okay, whereas if I plan a wedding in the first example and nobody comes, I'm not paying any. It's going to be hard for you to find a hall that doesn't charge that, by the way. Okay, and if I transfer this over to what we use for word problems, it's the cost. So the total cost is going to be $33 per person, which means n is the number of people, plus your initial fee, which is your hall rental fee. Okay, so I'm now flipping the page on 120, and you're going to see those are where those equations come up with. It tells you here to graph each separately, but I would always want you to graph them. Separately. Okay, so notice, folks, that I have my colors actually different than what the graph is on the next page. So I will try to coordinate this so they look better. Okay, so if we do choice A, which we'll maybe label equation 1, if nobody shows up, the cost is going to be 0. And then it shoots up like that. Okay, that's a steeper rate because the slope is larger. Whereas our second equation, although we start at 2,000, it has a less steep of a rate. Okay, so this is going to be, again, this is hall B, and this is hall A. Okay, or 1 and 2, whatever you want to discuss. Okay, and you'll notice, folks, that there is on the graph on the top of page 121, there is a spot where it intersects, and it says 120 comma 5,900. Okay, that's the point of intersection. What does that mean? If we're planning a party and 120 people come, both hall A and B will both charge $5,900. Okay, so here's one in real life situation. If you're going to have less than 120 people, so 119 to 0 people come, which company is going to be best? It's going to be hall A because it's lower on the graph. So between 0 to 119 people, hall A is cheaper. Okay. Whereas if we have greater than 120, so 121, so greater than 100, that's the greater than sign, guys. So greater than 121 people, hall B is better because it's cheaper. Okay. But notice, folks, at exactly 120 people, both halls, my fault, sorry, both halls will charge the exact same amount of $5,900. Okay? I will tell you, here we go, Miss R, the math geek. When I planned my wedding, I took my graphing calculator, yeah, the TI-83. I took it with me around town in London where I used to live, and I used to graph out each of their, each place that I went. I picked about 4 or 5 different locations to have my wedding reception, and I graphed it out, and then once I got close to the numbers that I needed for my wedding, that I chose based on food and location as well. But this is something you can do, especially for cell phones, guys. Cell phone market is so competitive right now. You should be able to take each plan, graph it out, and based on your situation, which one is better for you. This is about being street smarts, okay? And if you're comparing investments at different banks, this is also a great thing to do. All right, so I think I've talked enough, ladies and gentlemen. Here is method 1, which is solving by graphing. Here's your homework, folks, page 124, 1ACE, 3C, 6, and 8, and you will need actual line or graph paper to do your graphing on. Have a great day, folks, and see me if you need any help.